Hi, everybody. Let's learn another circle topic about different kinds of angles that there are in a circle. So, the first question is what kind of angle is angle one? Do you notice that the vertex of angle one is at the center of the circle? So, that is called a central angle. Now, take a look at angle three. Do you notice that angle three's vertex is not at the center of the circle? Angle three's vertex is on the circle. Angle three is called an inscribed angle. It's inscribed into the circle. It's like it's carved into it. So it says arc CB is 50 degrees. I'm going to label that on my picture. What you may already know from when we were looking at sectors of circles in the past is the central angle has a measure that's the same as the arc that it intercepts. So if the arc is 50 degrees, then angle one is also 50 degrees because that's how central angles work. What we don't know yet is how inscribed angles work. So we're going to use math that we learned previously in this school year to try to figure that out. All right, I'm going to find angle 2 because angle 2 is supplementary to angle 1. So 180 minus 50 is 130 degrees. Then something that you might not have noticed is that triangle DAC, is actually an isosceles triangle because this is a radius and this is a radius. So I can do 180 minus 130 to see how many degrees are left for angles 3 and 4. And then because there's two of them, I have to split that into two parts, and they're each 25 degrees. So notice that when I subtracted 180 minus 130, I got the 50 that I started with, and then I split it into two parts and got 25. So there's actually a relationship that's true every time, and that's that angle 3 is always going to be half the measure of angle 1 because of how supplementary angles and angles in an isosceles triangle work. So angle 3 is half the measure of angle 1. So now we know a little bit about how central angles and inscribed angles are related to the arcs that they intercept. Let's formalize this and take some notes. We have central angles and we have inscribed angles. For a central angle, its vertex is at the center of the circle. And if the arc is, let's say, 80 degrees, then the central angle is 80 degrees as well. But for an inscribed angle, its vertex is on the circle. And if its arc is 80 degrees, the inscribed angle is only half of that. So the inscribed angle's measure would be 40 degrees. So central angles have the same measure as the arc, and inscribed angles have half the measure of the arc. You just have to be careful because if you know the arc, you cut it in half to get the inscribed angle. But if you know this inscribed angle, you have to double it in order to get the measure of the arc. So let's practice that comment. So you want to, or this content, you want to ask yourself every time if it's a central angle or if it's an inscribed angle. If it's a central angle, it's going to be a little bit easier, and that's W and X. If the arc is 109 degrees, then the central angle is 109 degrees as well. If the angle is 92 degrees, the central angle, then the arc that it's intercepting is also 92 degrees. So that one we could do without having to do a bunch of calculations. But when it's an inscribed angle, we have to take half of the arc that it intercepts. So 98 divided by 2 is 49 degrees. But if you know the angle and you're trying to get to the arc, you have to double it. 41 times 2 is 82 degrees. So Z is 82 degrees. Let's try to put those concepts together and do a multi-step problem. So it says angle JKL, which is a central angle because the center of the circle is K, is 44 degrees. So first thing that it asks us to find is JL, that's the arc that it intercepts. So it's a central angle, so that arc is also 44 degrees. Then it asks for JHL. That's an inscribed angle. So that arc is going to be half of 44 degrees, which is 22 degrees. Then it asks for the measure of arc IH, Well, it doesn't look like we have anything over on that side of the circle yet, but when I use vertical angles and I have a 44-degree angle, then I can see that that arc is also going to be 44 degrees. All right, then the next thing that it asks for is the measure of arc HL. So this isn't something that we've talked about yet, but IL is a diameter of a circle, so it cuts it in half. So a semicircle has 180 degrees. That is not what I meant to highlight. Let me try that one more time. Oh, I don't know why it wants to highlight that. How funny. All right, we'll give it one more try. If it doesn't work, I might just have to give it up. Oh, there we go. That's what I was trying to highlight. That's 180 degrees because it's a semicircle. And if a whole circle has 360 degrees, a semicircle has 180 degrees. So I could just see what's left from 180. So 180 minus 44 is 136. All right, arc ILJ. So this is really important. You need to make sure when you're finding an arc with 3 letters, it means it's a major arc that's more than 180 degrees. You need to start at the I and go around toward the L and then toward the J. So you need to make sure that you're going in that order. Don't go from I to J to L. That's what the next one is asking for. So when I go in that direction, I do 44 plus 136, which we know is 180, plus another 44. 44 plus 136 plus another 44 is 224. All right, now I'm going to erase that and I'm going to go in the other direction from I to J to L. Oh, that's just the semicircle. So that's just going to be my 180 degrees. All right, so that gives you a little bit of information about inscribed angles and central angles and how they're related to the arcs. Let's do one more thing, and that is to look at what happens if a quadrilateral is inscribed in a circle. Well, do you notice that this angle here that has an X by it is an inscribed angle? So I can add up these two arcs, and then angle X is inscribed in that arc. So 85 plus 63 is 148 degrees. And then angle X must be half of that. Half of 148 degrees equals 74 degrees. So we can use that idea to work through an entire quadrilateral. So first, I am going to look at this 120 degree angle here and this arc that it intercepts. So 120 is the inscribed angle, so I'm going to double it and get 240 degrees. So when I'm trying to calculate how much is left over for CD, I can do 240 minus 125, and I'm left with 115 degrees. All right, let me erase that, and then I'm going to do something really similar with my other inscribed angle, which has a measure of 70 degrees. This highlighter has a mind of its own. All right, I'm going to switch colors here. 70 degrees is the inscribed angle, so that means that the arc that it intercepts is twice as big, which is 140 degrees. So if I want to know what's left for arc BC, I can just do 140 minus 115, which is 25 degrees. And then I think the best way to figure out what's left over is just to use the concept that all of those arcs should add up to 360 degrees because there's 360 total degrees in a circle. So let me grab my calculator. The eraser isn't necessarily wanting to erase everything that I want it to. All right, I'm going to add up. Let me switch colors one more time. I'm going to add up 25 plus 115 plus 125 and see what I get. 265. Then I can just subtract from 360 to see what's left over. 360 minus 265 should be 95 degrees. So now we have all the arcs. There are a couple of inscribed angles left to find. So I'm going to show you sort of the long way, and then we're going to notice a cool pattern. So I'm going to highlight angle D. Then I'm going to highlight the arc that it intercepts. It looks kind of like an ice cream cone. I'm going to add 95 and 25. And that is 120. 95 plus 25. 95 plus 25 is 120 degrees. And then I can take half because it's an inscribed angle. So 120 divided by 2 equals 60 degrees. All right, you might have a couple of ways that 120 and 60 are related to each other, and I don't want you to draw the wrong conclusion. So before we make any assumptions about how those are related, I want to draw one more of those ice cream cones. Let's see if I can get the highlighter to do what I want. I'm going to highlight angle C and the arc that it intercepts. I'm going to add up 95 and 125. 95 and 125 adds up to 220, and then cut that in half because it's an inscribed angle, and I get 110. All right, I want you to take a look at something. 120 and 60. I mentioned that there's a lot of different ways that those might be related, but look at the 70 and the 110. Those add up to 180 degrees. Does that work for 120 and 60 also? It does. So that's actually a really quick way if you have an inscribed quadrilateral. It makes sense because all of the arcs put together add up to 360. So whenever you're figuring out how much is left over for the inscribed angle, you figure out what's left from 360 and cut it in half. So if the arcs all add up to 360, it makes sense that those angles add up to half of that, or 180. So that's a little shortcut you could take, but if that's not something that you remember, you could always do it the longer way and just work with the arcs and the angles. Hope that helps. Let me know if you have any questions. Bye.